This is another example of an application of combination theory. It says there are 6 lines in a plane. What is the maximum number of times the lines can be intersected? And there are multiple ways to do this. One way is to start looking at lines, and if you intersect 2 lines, they intersect in one place. If you do it in 3 lines, the maximum number of ways would be 3 intersections. If you did 4, it starts getting harder and harder to draw these. But what you start realizing is all you want to do is each pair of lines have to intersect each other to be the maximum. So the question then is, how many pairs of lines are there? Well, if we ever want to find out how many pairs there are, that means how many sets of 2. And so that's the same as saying you got 6 lines. How many ways can I pick 2 of those lines? And so the answer is just going to be 6 choose 2, which would be 6 times 5 over 2 times 1, which equals 15. So if you've got 6 lines, there are 15 intersections, or the maximum number of intersections is 15. If you put 6 lines in a plane and there weren't 15, that would mean you either have parallel lines or you have lines, more than 2 lines that intersect at one point. If you had 12 lines, it's the same problem, except you just do 12 choose 2. And 12 choose 2 is just 12 times 11 divided by 2 times 1, which is 66. And so you can do that for as many lines as possible, and it's the same theory. Example 2 is a little harder. It says you've got 8 lines and 2 circles. What's the maximum number of intersection points? Well, you use the combination theory for the lines. 8 choose 2, which is just 8 times 7 over 2 times 1. And so for the lines, they intersect each other a total of 28 times, right? 8 times 7 over 2 times 1. But then you got to look at the other cases. The next case is if you have a line and a circle. Well, the maximum number of times a line can intersect a circle is just 2. So how many ways can you have a line and a circle? Well, 8 lines, 2 circles, that's 16 combinations of those, and so you just do 16 times 2. So there's 32 intersections between lines and circles. And then finally the 2 circles could intersect each other twice, and so we add 2. Add all that up and you get 62. And so part of the problem was using combination theory, and then you had to use some logic about looking at how many ways the lines and the circles would intersect each other.